Hello, welcome to CEO's Projects. Today I'm going to talk about the battery that I made for this electric skateboard. To start off, I have to give you some context on the batteries I've made before. I made batteries such as Liver, which this was for Walmart Special, the bike that I had shown in previous videos. It was a really great battery, horrible cells, so it ended up going, out to pasture really quickly. Then I made 3TFA. I actually forgot what it stands for. This is a kilowatt hour battery. Well, it's 1008, but we round down a little bit. It is a 14S 4P battery with 21700 inside of it. Each are Samsung 50Ts with 5000 milliamp hours per cell. So it's a pretty darn good battery. It used to have a BMS, which used to go over here, but that thing died. Then I bought a cheap one, and that one also died. So I've just been charging it and then using an active balancer from 100 Balance, which is really, really helpful. And that's sort of been it. And I also, of course, 3D printed the case, which was really helpful. Now, also inside of here, these things that are holding the cells are also 3D printed, which has been sort of the basis for how I did the holds on this thing. So now, getting to the new boy we have here. So to start off with, this controller actually was broken in great disrepair, and I actually had to repair it to the thing, pair as in like, now it actually talks to it, but the battery was literally not present. The throttle was also not really working, so I had to fix that as well. And yeah, so I'll have a video of a close-up here, but there's tape everywhere. It's not because it's broken, it's because, well, I don't want to slice my hands open on the plastic, because I used a soldering iron, but it wasn't as great as it normally would be. But it works perfectly well now. But the person who had originally taken this thing apart and this thing apart stripped so many screws, it almost became impossible to replace it. There are screws actually missing from here because of that, because of the fact that they just destroyed them. But thankfully, I had enough bits to get them out. Now, the charger. This is a standard 42 volt charger. It is 2 amps, not the fastest, but it's safe enough because I don't know the cells, which I'll get to that about, but I don't know sort of the limits for charging the cells, or just, well, I know discharging the cells, that I had to know. But this is just a safe bet. It doesn't heat up, thankfully. And so it originally was for battery for this skateboard here, because this has a 42 volt battery in it, and so I would just plug it in. But the only problem is, though, I had to take off the cap. And so all I did was I created a XT60 to DC barrel plug connector, which was pretty easy and actually looks really nice. And well, then I just plug this into here, which I'll show photos of that later. But it charges up pretty quickly. Well, not quickly. It charges up slowly, which is good because the faster it charges, and that means the worse the cells are getting, technically. But now that we have the charger down, we then move on to sort of why I made the cells. I know I'm not talking about the battery yet, but the reason why I had to make the cells, which I'll have make the battery, which I'll show here, is the wheels on this thing are literally cracking and snapping. The whole thing is starting to fall apart, and the wheels, since they're vinyl, are, like I said, falling apart. And I can replace these 2 front wheels, but I can't replace these 2 back wheels, because these 2 back wheels are the motors. And the screws are so rusted, as shown here, that I literally can't remove the sleeves. So I can't remove the wheels. So once these things split, I'm effectively, this thing's dead. Which stinks, because I'd have to buy a whole new setup, which at that point, it would cost about the same as just buying a new skateboard. So, yeah. But the battery in there could still be good. And of course, this is also V5. We had V6 and V7, but yeah, they both died and ended up going with V5. So, now, finally, to the actual battery. So, I can't really take this apart. I mean, I can, but it would be a not very fun experience doing so. So I did take a lot of photos while I was actually building it. Now, this thing, as you can see, is a longboard. It is not what I expected to buy. I bought this for $140, which is a pretty good steal considering that this board, it's a Vestar something, usually retails for about $1,000. Now, there's a little plug here, which I'll show more in depth, but this plug is how I actually tested the battery in, what do you call it, like before I had gotten the, before I had actually built the cells. So I'm going to show you a quick video of how I actually tested it, which is pretty much me putting this thing on the just like plugging a battery in here and going. Alright, so this plug is also 3D printed with TPU. It was actually the second design that I had to make because the first one just didn't fit, but this one, it fits perfectly, and since it's TPU, it goes and it sits perfectly in there. It just sits in there, and it also curves to the curvature of the board, which is amazing. And so, doing testing for this, I needed to find out what was the max current pull, what was the, well, I knew the voltage, so I need to know the max current pull, which would tell me the max wattage that I had to rate the battery for. And then after that, pretty much everything was just design a battery to fit inside here. Now thankfully the battery, which I think I have a photo of, used cells that were 18650s that were this many milliamp hours. Now these cells are arguably bad, which is good because the cells that I had gotten, or that I planned to use, were good. Now the cells that I had gotten came from a Bosch PowerPack 400. This was a battery that I helped remove from a bike with aid of the police, and pretty much I got to keep it. Now these cells were perfectly fine. The only problem was though, they had nickel strips on them, so I had to remove 40 nickel strips. Well, not 40, technically 80 because it's 2-2, but regardless, I had to remove the cells, sand them, get them all nice and safe. Now these cells were good cells because the bike had barely been used. They had just forgotten to pick up their bike. And so when that happens on my campus, well, they disappear. Legally. This battery was given to me by the police, so we were all good on that part. So I pretty much took the cells, tested them. Since I had charged them in an attempted video that I made a long time ago, they were all the same voltage within 1,000th of a volt. So I was perfectly set because apparently inside of it had an active balancer, which is really helpful for me. I couldn't utilize it though because it needed a data connection, which is, I wasn't going to spend time emulating that. So those cells are right here, and so then we get to the fun part, actually building it. Now, I said previously mentioned with this thing that it had inspired the way how I actually created the holders for these cells. Now, if I can find a photo of it, here's a photo of what the cells look like internally on here. Ignore that big red wire. That big red wire is sort of an impromptu bus bar because, well, I didn't have one and I need to figure out something to hold 20 to 60 amps of current. So I took them, put them together like this. This was the original version. The original version pretty much was 2 pieces for a single side. So it would go and it would connect in, well, like this, sort of. And so it would slot in like that. And that slotting in, using a friction fit, would hold the cells together. And this was easy because it allowed me to 3D print on small stuff like the Ender 3s, but I ended up sort of not wanting to go with that idea, as you can see with the beginning of the video, or I'll replay it again here. So, as you can see, it would fall apart and also added a really solid amount of space. I think it added about 15 millimeters of space, which inside of something that you really don't have a lot of space, that's a lot. So what I decided to do was I decided to see if I could print it on my new CR10 Smart Pro that was, well, that I acquired for a solid amount of money. And so I actually printed it on there in one piece. I just altered the design, removed the space in the middle, and printed it. And the benefit of this would be single part, which means I don't have to worry about multiple parts failing, all in a line, and it's also a lot smaller. I mean, that 15 millimeters actually ended up being exceptionally vital once I had put everything on there. So then you get these cells. So these are the actual stacks that were made. Now, from there, we go and we start making the battery. So as you can see, this was sort of the way how the nickel strips were all set up. Now, they were set up, but that's not how they ended up being made. So the reason why you have those tabs on the end is so that you can solder the balance wires to them. I'm of a mind of where you never want to solder to the battery or the cells. Why? Because a hot lithium cell is not really, well, safe. So what you do is you put solder on the strip that's the little tab before you do it, so then all you need to do is just tap the soldering iron on there with the balance wire, and then boom, you're good. Now, I originally was going to use a big spot welder that the club had. The only problem was, though, the last person to use it didn't do it well. And so I had to buy my own, which I'm going to go grab right now. I bought this. This is an A with Z H2 spot welder. Now, you might say, oh, it's a portable one, and it wasn't that great. I was able to do, what was it, either 40 or 60 spot welds on this thing before it overheated. Not died, overheated. That's crazy for a portable device. Plus also, it comes with a pretty darn good warranty, so if something does happen and it does die, they will easily send me a new one, which I find very great. This is also not sponsored at all. It's just, I paid, I think, $40 for this. I would have paid $100. This thing's really good. Plus it comes with extra tips. It comes with a manual and automatic discharge. And it feels nice when I was doing it. And so compared to the one that we had in the makerspace, or not makerspace, the club, where you had to pretty much take down these two large tips and you had to go and pop them down. Like, yes, it was a capacitor and it didn't overheat, but pressing down on them really didn't help. Meanwhile, here, being able to press down lightly and pop it was very nice. Now, I was also suggested, which was difference between this battery and this new one, was to spot weld one of those strips onto the cells, like spot weld it strip by strip. I was going to need two strips of, two strips of nickel strips. These nickel strips are, well, bus bars, effectively. They connect the cells in parallel and series. And so I needed two. Now, two, trying to spot weld something like that, that'd be 0.2 millimeters thick. This can do that, but not really well. So they suggested I do one and then two. And that also helps remove the gaps. Now, I was sort of skeptical of that until I did it, and I realized, wow, it really does make a difference. So if you're ever spot welding a battery like this, do a single layer and then do the second layer. And so I would do a single layer, second layer, and then battery management tab. So, and this, again, if you're looking for something, buy this. If you can't use it, I mean, it's a skill issue at that point. I'm sorry, but it's a skill issue. This was literally perfect for me. And if honestly, if you have a problem, just message them. They were literally sending me videos. I'll pull it up here. Sending me a video on how I should spot weld it. That's how much they care. So, I mean, they get a 5-star review from me for customer support. And again, this is not sponsored. I just needed something quick because I was not going to wait 3 weeks for replacement tips. So, now we get to the testing of the actual battery. So what I'm going to show here is a test of the battery, pretty much doing a no load plug-in test, which pretty much means I go literally like this. I take the thing, put it upside down. Granted, here I also have the thing upside down, and I just go like this. And what that does is it tells me how much wattage it's pulling without load, in other words, without me on it. And I can tell you, it's a very large difference. As you can see in the video, if you can't really see, I'll try and grab a screenshot of it. This pulled around 170 amps. Or sorry, 170 watts of power. It was 170 amps. That probably meant that this would become a Ghost Rider skateboard because everything would be on fire. But so it pulled 170 watts. Now, when I went on it, I don't know if I have footage of it. Actually, I think I do, but it's for when I was testing the battery that was in there and doing the thing on top. This thing pulled 1,000 watts. And one thing that I don't have when I was filming, or testing it, is I was looking on here. Now, this remote has 3 bars on it, right here, to show pretty much how much power is left in the battery. I hit 1,000 watts. and it didn't even go 1 bar down. That's how insane this battery is, which I'm super happy. Which, by the way, I am discharging through a BMS. The BMS is right there. It's like circled or something in the photo, but it really astounded me. I'm able to get around 10 miles on flat land out of this thing on a full charge, which is, to me, pretty insane. And so, I mean, that's sort of it. I'm able to hit around 30 miles an hour without death wobble. Well, actually, no, I still get death wobble, but thankfully I can just get out of it. But I was able to hit 30 miles an hour on this at one point. I topped out. And, yeah. So this battery, to sum up, made from reused cells that were tested and made sure that they were fine. A BMS that is more than rated for 1,000 watts because I'm not a moron and I want to be safe. And the motor controller and stuff were already in there. Now, one extra thing about this controller is in this battery, I have to remove this casing, this little bar right here. The problem with that is it's annoying and you don't want to do that. So by being able to utilize, and I'll have a photo of it here because you're definitely not going to be able to see it, being able to use this DC barrel plug here to charge the battery makes my life so much easier. I mean, you'd be surprised because then I'd have to go and take it out, find somewhere to plug it. Meanwhile, this, just plug it into the side. I know it's gonna think it's a sketchy explosive because a lot of the comments that I had gotten on stuff like this and all the other batteries I made were that it looks very sketchy, which they look sketchy, but they're far from it. I take so many safety precautions when making the batteries because it's very simple. If this fails, well, at least if that fails and it explodes, I die. If this fails, or even just stops, like let's say I drain the voltage sags so much, it just stops and turns off, it throws me off the skateboard. Now, I don't know how to fly. And since I don't know how to fly, if this stops, I'm sort of going to have to learn very quickly if I can. So, I'm very happy though with this entire thing. I mean, for $140, well, technically plus 40 because of this thing, I am very happy. I mean, it goes very fast. Everything on here is replaceable. The wheels are replaceable. The belts are replaceable. The motors are replaceable. Everything's replaceable, unlike this, which is not replaceable. So I have a longboard that I can go very far on, replace pretty much everything if something goes wrong. The battery is internal and I can charge it internally, and yeah, and it cost me almost nothing. Plus also it has brake lights, which it's nice. So I'm really happy with that. So if you're still watching, I'm gonna now explain sort of where I've been for the last God knows how many months, this many months. So once this work on my senior project, one of the last few videos I made was me making micro lenses. So I ended up actually being able to fully fabricate an optically viable micro lens that had about 95% efficiency compared to the actual. Some of them were actually better than the actual because, I don't know, they just were. I literally could not fake the data because it used raw sensor data, so I literally could not fake it. I still don't know how I could fake it, and that was a funny thing on my exam. Or not exam, but people were asking stuff and they said, how could you fake the data? And I said, I don't even know how I could. Because I don't know how you fake raw sensor data, but pretty much I created this thing called LDAR1, which was a lens data acquisition rig. I'll have a photo or some photos here while I'm talking about it. And that pretty much went and it measured the created light or through a laser diode, and pretty much it filtered it through the lens into a CMOS sensor, which was a Raspberry Pi camera that I delidded, which was utterly horrifying having to do it. And so, yeah, and we found out that the lenses were actually viable. The polishing method that I had was really, really usable and repeatable, which is the big deal. And yeah, we actually ended up getting second place at the URC, the UNH URC, because I had made first place's project. I had soldered a bunch of stuff for them, but in return I got notes. But am I mad? No. I got $150. Their group got $125 per person. So But we got second place. It really worked, and yeah, but it took a lot of my time and my stuff, so I really couldn't upload any videos. And even if I wanted to, the stuff that I was doing, I was actually informed to not release any videos because of how unique and original the stuff was. And if I did end up ever wanting to file a patent, if I had any more information out there, they were worried that someone could clone it. So yeah, but this process, I was actually able to make a lens for NASA, and it worked really darn well. I mean, they were really astounded with it. They were very unhappy that I didn't give them the rig that I had made. But that's because of the fact that I don't own the rig. I own the parts on the rig, but the actual linear actuator itself, this part, here's the McMaster-Carr thing for it. Yeah, you can see it's not cheap. So I had to, I mean, it's on loan from my uncle. Loan as in, until I need it, it's yours. So yeah, but that's pretty much where I've been. I promise I haven't forgotten about this channel. I've been trying to figure out an idea to make, but once I finally made this, it was, I knew there was something. I had made this on my campus before I had left, so I just wanted to finally make a video now that I've mostly unpacked from coming back from college. And yeah, oh, and one last little thing. I, because of my project, have gotten into Columbia University. I talked about it a lot on my application and everything else, because it truly was a whole new experience, learning how to create all these technical data packages and everything else. And I also got an internship with the Southwest Research Institute, helping them with well, additive manufacturing of high accuracy optics. So it's been really helpful. So I don't know, everything's been great. Just wanted to let you know that I didn't forget about you, that I was doing stuff, important stuff that I literally, legally cannot tell you what I've been doing. And yeah, so thank you so much for watching, and I'll hopefully see you next time.